Friday the 23rd of February. Have a look at that moon. Tomorrow, I think in the morning, about 5 o'clock in the morning, it will be full. But it certainly appears that way right now. Tonight's endeavors are basically going to be Mathematica Galactica. We're not going to get very good views, for that obvious reason. There are some high thin clouds that get more visible when the moon is bright, so more light is reflected back into the aperture of the scope. I don't expect to get much of any interest, but I want to pursue 1, 2, 3, 4, something I've discovered about the relationships between the various bands of luminosity associated with galaxies, and the 1, 2, 3, 4 characteristic is principally associated with lenticular galaxies, spiral class O's that I call Z equals 0 in the range of galactic evolution, let's call it that. And the luminosities of the various components of light and infrared and long radio wave emanations coming out of galaxies, which shows a very interesting set of correspondences. Let's get started. Let's start with a look at Rigel. I just synchronized the scope to it. It's getting tougher and tougher at 150x to make sure everything centers anywhere near the middle of the screen. In fact, sometimes things don't even turn up on the screen. I have to make sure I synchronize to the part of sky that I'll be imaging at. In this case, we're going to be spending a lot of time in Lepus, starting with galaxy, I believe it's NGC 1954, that I have already imaged under probably better circumstances than right now. But I've synchronized to Rigel, and we are going to go on and have a look at some favorites, Messier class favorites, and NGC 2024, the Flame Nebula, before we launch into galaxies, because we haven't quite achieved sky dark. Time now is 6:45, roughly. While you can see Messier 42 in the upper left-hand corner of the screen, we are looking at Messier 43, the conch shell nebula. In Orion, magnitude 7, it's 20 by 15 arc minutes, which means it's probably about an average surface brightness of 14 magnitude. I'll maybe run the calculation later. We're at -5 and change degrees in declination, and that's a surprisingly decent view given the fact that we are having to contend with a full moon that's probably some 670 degrees to the east and slightly north of our current viewing location, which pretty much is very close to culmination at this point. Here, of course, is a vastly overexposed Messier 42, the great nebula in Orion, although the virtue of overexposing it is we're getting some really nice texture well away from the hot ionized region of the nebula itself. This, as you may know, is a star-forming region, fairly young, probably not much more, certainly less than 1 million years old. Nebula in Orion, magnitude 4, 90 by 60 arc minutes, 1,600 light years distant. We're at -5 and almost a half degrees in declination with a right ascension of 535, 15. On to the Flame. And if we get a good look at that, I will be very surprised and very pleased. Given the fact we have high thin clouds and we have that full moon looming to the east. You're now getting a chance to see why this is not a Messier study. NGC 2024 is Nebula in Orion, full moon sized, barely visible on the screen, 30 by 30 arc minutes. It's an emissive type of nebula, 1,500 light years distant. We're at -2 degrees. It's very close to Alnitak. On a very good night through a largish amateur scope at the eyepiece, say 12 to 18 inches, you can make out the Horsehead Nebula, and that is something that can be made out using real-time imaging with the 6-inch refractor that I see before me. If you are seeing a bit more of the Flame Nebula now, it's because I have just boosted the settings for the Rev 2 imaging system to the maximum of 256 flood, which means 3 seconds exposure plus times 6, 18 seconds with image stabilization really means it's going to take about a minute for this image to really pop, if it's going to pop at all. Unfortunately, any motion on my part, except perhaps my lips, may disturb the image formulation routine and result in not such a good image. However, the stars are looking pretty good right there. Now, the reason why I've boosted the gain, or the sensitivity to 256 flood, is because a figure that might help in looking at some of the galaxies that we're going to be recording this evening. So yes, indeed, there is some faint luminosity plus a darkish region here in the Flame Nebula, although I can't see it so very well on the actual TFT monitor. It is coming out pretty decently on the Handycam screen. So now we're looking at sky about as dark as the sky is going to get, and we're going to push off, and hopefully we are going to be able to track down the galaxy series of 7 or 8 galaxies that I've selected for the evening. They're all down towards Lepus, south of Orion. May not get very good views, but at least I can capture the data, and if we can see anything of them, I will appreciate it. That way this video, which is going to be a Mathematica Galactica video, won't be as boring as it might be otherwise. Should be able to see the residual image of Rigel on the screen. I did a resynchronization in hopes that it would help us to be able to track down NGC 1954 Galaxy in Lepus, selected because it's bright, magnitude 11.8, large, 4.2 by 2 arc minutes in size. It's a spiral 2.5 times removed from the lenticular class O as a spiral BC. So if you see a B and a C, that basically in the Hubble de Vauquelaire's morphological system, it's halfway between a B, which is 2 times removed from lenticulars, which is the crossroads of the tuning fork of morphology, and the C, which is 3, so 2.5 times. If we're seeing a galaxy up there, I couldn't tell you. I'm happy we're actually seeing at least one star. There may be a galaxy present. There may not be a galaxy visible on the screen. But I do want to point out that we're going to spend about a minute here. What I have discovered in my wavelength brightness studies of galaxies. Galaxies are characterized by a very large spectrum of frequencies or wavelengths of light. There's 5 basic ones that are monitored by astronomers that I'm aware of. There is the blue-violet, which is something like 445 nanometer wavelength. There is the green-yellow, which is something like 454, don't quote me. Then you have 1220, which is the J, which is an infrared, and typically it's an admixture of re-radiated light and ionized radiation, possibly, plus the radiation of stars of very low mass, typically 1/15th, 1/10th to 1/20th of our own sun, which are able to do some nucleosynthesis, but do not synthesize much beyond hydrogen and helium. So, and then there's the H and K wavelengths, which are something like 1800 and 2200, but by the time you get to the H and K wavelengths, the difference in luminosity gets to be very small, typically around 0.25 magnitudes, with the longest wavelength, the K, slightly brighter than the shorter H. And all of these things can tell us something about what's going on in terms of galactic evolution, because there may be some interesting correlations to morphology. Now, I am noticing that I'm seeing high thin clouds to the south in the region we are now viewing, which may explain why we're not getting much of anything on the screen. Now we've made the leap to a fainter galaxy, and I'm not going to spend much time on this. NGC 1957 appears to be a neighbor of 1954. It's magnitude 14.8, and the reason I selected this galaxy for a view is twofold. One, that magnitude value of 14.8 is not really clear about whether it is the blue-violet range, which tends to be about a magnitude fainter than the visual green-yellow. So the question is, I have to look up the data to be able to determine that. I suspect 1957 is blue-violet magnitude 14.8. It's an elliptical galaxy, and typically elliptical galaxies, this one happens to be 1.1 by 0.8 arc minutes, it's probably an E3. But typically elliptical galaxies have older stars that are glowing at less brightness in the higher wavelengths, so shorter wavelengths, and brighter in the lower wavelengths. So typically in an elliptical galaxy, you will see a value for a delta, which is called the BV index, between the blue-violet and the green-yellow, exceeding that of a lenticular type, which typically has a value of 1 magnitude or 2.5 times brighter on the visual over the blue-violet. And in terms of elliptical galaxies, that can be a value as high as 1.5 magnitudes different, which indicates the stars are much older, many more smaller, long-lived stars with very few massive star progenitor types in the realms of 2 to 15 or 20 times the mass of our own sun, which do not live very long. So there is our little discussion of NGC 1957 and what it might be suggestive of. Whoop, we just had, hey, that was worth it. We just had a meteor pass right through the 10 by 15 arc minute 150x field. Interestingly enough, I have just run the brightness of the TFT screen down to about 10 from a peak of 30. Because we're getting those high thin clouds, they're being illuminated by the moon, it made sense to actually reduce the brightness of the screen. So what we are looking for here is something that appears to be right there in the upper part of the screen, and I can't be sure that's it. Could very well be it, and if it is, boy, is the modeling off on the scope that is basically looking west. This should be NGC 1954, Galaxy in Lepus, magnitude 10.8, large, 5.5 by 2.1 arc minute spiral with the bar in the lowercase b. Barred spirals in the Hubble divelculaires are at the bottom of the tuning fork. They have elongated core regions. And if it's also a lowercase b, that simply means it's twice removed from the lenticular class. So if we're seeing a galaxy at all, it is right there. And I may try an experiment by driving it down to this part of the screen and then revisiting the previous galaxies, because they may very well have not been on the screen at all. Okay, I've had to drop what I suspect is NGC 1964 down from about right here to here, and then cut a right angle orthogonally to where it is visible right there on the screen. Then I've synchronized. Now this is an experiment. I'm going to go back to NGC 1954 and see if it can turn up. Well, that's very satisfying. We're back to NGC 1954, and it is visible right about the same location as I think that was 64. Galaxy in Lepus, once again, magnitude 11.8, largest 4.2 by 2 arc minutes. Spiral with a lowercase bc, so it is probably, it could be on the center of the tuning fork, but it probably has a round core. 134 million light years distant. We're at minus 14 degrees. I can see high thin clouds being illuminated by the moon in the distance. And whatever we might have seen of this galaxy is gone. I will not go on to NGC 1957. We'll go back to on from NGC 1964. From galaxy year 1954 to 1964, we've now leaped to galaxy year NGC 1979. Galaxy in Lepus, magnitude 11.8, smallish, 2.2 by 1.8 arc-minute lenticular spiral, a mere 68 million light years distant. This is probably a lenticular that's only about 40,000 light years in diameter. We're at minus 23 degrees, and you can see the galaxy right there. It did not pay off. Maybe one of the reasons I'm having trouble with modeling is that stars are just not reliable in terms of their celestial locations for that purpose. But here we have it. I see two galaxies, a brighter one there, which is NGC 1979 at 11.8, and a fainter one there. So it might almost behoove us to go back and check out that 14.8 magnitude NGC 1957, just in case it can be turned up. But there is our view of 11.8 lenticular spiral. And what have I said about lenticulars? Typically, the magnitude difference between the blue-violet and the visual is 1 magnitude. The difference between the visual magnitude and the J magnitude is typically 2, which means the difference between blue-violet and the J magnitude is 3. And then the difference between the blue-violet magnitude and the K, which is the longest frequency, is 4. 1, 2, 3, 4. By 1979, we were no longer fighting for in terms of the Vietnam War. Okay, just a quick check to see if we can turn up NGC 1957. 54 is quite apparent there, the core of it. Ooh, it just shifted. Did I move it? Anyway, 57 should be right about in this location here. I will give it a few seconds, 10, 20, 30, 40, 50 or more, to see if it formulates. But I am kind of noticing something very faint right there. And if we really are seeing a 14.8 magnitude galaxy, that is clearly the blue-violet, and the visual brightness, green, yellow, being about a magnitude to a magnitude and a half brighter, because this is an elliptical galaxy, would actually be somewhere in the realm of magnitude 13.2. Well, I'll inspect it mañana. We're off to NGC 1993. That was pretty close to the year that we built our first computer living in the Bay Area. And then after that, my son went on to get himself deeply involved in computer programming, network, hardware, software administration. Really set him off on a really good path. What we're looking for here, NGC 1993 is another galaxy in Lepus. Brightish, magnitude 12.4, but smallish, 1.5 by 1.4 arc-minute lenticular spiral, 135 million light years distant. This galaxy is probably about 70,000 light years in diameter. We're at minus 17.75 degrees in declination. There does seem to be some fuzzies there and some stripy type stuff there. I don't know, maybe I'm moving around. It's possible we are getting a view of it. Anyway, this is a lenticular spiral, and what's that relationship again? Well, this could be a 12.5 visual, which would mean it is a 12.4 visual, which means as a lenticular spiral, it would be blue-violet. What was that? 13.4. The J magnitude would be 2 less than 12.4 or 10.4, and the K, which is the longest frequency, would be 4 less than 13.4, which would be 9.4. Something to check on tomorrow's Mathematica Galactica. And yes, it does appear to be a galaxy there, which is different than these weird things here, Copitos presentation studies. NGC 2076 is another one of those galaxies in Lepus the Hare. Magnitude 13, 2.2 by 1.3 arc minutes, spiral with a lowercase a, which means it's one time removed from a lenticular. 99 million light years distant, puts it at probably about 60 to 70,000 light years in diameter. We're at minus 16 3/4 degree in declination. And looking at it, we're pretty much to the eastern half of Orion, but to the south. As far as seeing any galaxies up there, boy, I could make out something really faint in the region we've been looking at. So why don't we just get the data on it? As I said, magnitude 13, could be 12. Well, it's a one time removed. Typically, as you get further and further away from the lenticular class to the right, the Z plus series, the delta between the blue-violet and the visual brightness and magnitude tends to get smaller because they are forming stars out of cold dark matter. Those stars are very bright. They put out a lot of energy in the higher frequency, shorter wavelength range. NGC 2089 is the last in my pre-selected galaxies. It's also in Lepus. Bright, magnitude 11.9, 1.9 by 1.2 arc minutes, so relatively small. It's a lenticular spiral with a bar. A bar would mean that there is some extension out of the central bulging core of the galaxy of star formation, of higher density than you'd expect to see in a more globular, roundish core. The galaxy is 131 million light years distant. We're at minus 17.5 degrees in declination and 5 hours, 47 minutes, and 51 seconds. So what I'm going to do is just poke the next button on the Gemini 2 hand controller. If something comes up of interest, maybe we'll head there. But I'm seeing something that looks somewhat galactic right at the tip of my finger. Okay, I did discover another galaxy in Lepus. Now I do want to point out that we don't have many galaxies in Orion. And as we head further to the east, we're going to start running into the winter Milky Way. And we're going to see a lot more open clusters and a few globular clusters. There's a nice glob in Lepus, by the way. But anyway, since we're focusing on galaxies right now, and I am not doing the NGC catalog series sequentially, I'm just basically poking around with the scope. And this is featuring Mathematica Galactica with very poor views, but suggestive. We now have arrived at NGC 2106, the last galaxy we are going to be viewing in Lepus. And for the evening, magnitude 12.1, 2.7 by 1.4 arc minutes, so it's basically an obliquely presented spiral with a bar and a lowercase and a capital O, which means it's a lenticular barred galaxy. 83 million light years in distance, puts it at about 75 to 80,000 light years in diameter. We are at minus 21.5 degrees, 5 hours, 50 minutes, and 46 seconds. Let's have another look and see what we might make out in the flame as our Carpe Noctem view. Okay, we are making out a little vague nebulosity, emissive types associated with NGC 2024, the Flame Nebula. And it's well positioned on the screen. It would seem to me that after aligning the scope to actual galaxies, which aren't as drifty as stars, I think, in terms of having some kind of intrinsic motion relative to the Earth, obviously, that we are getting better centering in terms of the scope. And the view we're getting of the flame, I'm not getting much of a view once again on the TFT monitor screen, but I am seeing it vaguely on the Handycam. So let's sign off for this evening, probably about 10 to 12 hours before the actual time of the full moon, and say Carpe Noctem.